Just we said the rules of the game. Is it okay for you to see, or should I put it bigger? Yeah. Okay. The rules of the game, the material to check, where are we in the course, what is the pensum, what are we going to cover, and yeah, fundamental knowledge, where are we, how is the life cycle, and then we talk. It was a bit boring, but was just to give you a full overview and what kind of tasks you have in the process, field development process. Okay, and it's very similar to the life cycle, but there are some things that are specific of the development process. Okay, and I told you it might be slightly different depending on the company. And today we're going to finish this, and then we're going to discuss some things that I think I told you to read. So I hope you took some time to read from page 9 to 17. One of them is the difference between onshore and offshore. We are focusing in this course in offshore, but onshore it has some differences. Then you have differences between gas and oil that is very important and gives you a totally different behavior or totally different planning of the asset. Okay, and then the third one was we're going to try to talk a bit about plateau. Okay, relationship between plateau and length. Okay, so before we start, any question from last class, from last session? No. Okay. So the final step that we discussed last class was the issue of the PDO. Okay, plan for development and operations. So we continue. Let's put it here. Field development process. And this is kind of the end of the field planning process, or the field, how did we call it last class? Field design, I think. Okay. What we call project planning. Okay, project planning phase, the final product is the plan for development and operation, also called more generically FDP, Field Development Plan. FDP, Field Development Plan. Also in Norwegian, Plan Forutbygging og Drift. And I'm not sure if I will risk it to write it in Norwegian, but maybe some of you might. Bygging og Drift. Can give me some corrections. One too many G's. Bygging og Drift.
No, that's good.
That's okay?
Yeah.
Okay.
But I think you should have a blog for.
Yeah. Okay, and that's a final document that summarizes kind of already all the process that you have done so far. All the screening process, all the reserves that you have, all the structure that you think you have, all the development concept that you're going to use, what is your time schedule, how much are you going to produce. Many things are included in this document. And I don't want to go through all of them because it will be a bit tedious, and that's not the purpose of the class. But in the compendium, if you go to page, let's see, what page will that be? Okay, this page, some notes by Professor Michael Golan, the creator of this course. It's in page 42. Okay, so he describes all the content that usually the PDO has. Okay, if you go also to internet and you search for, I think I showed you yesterday, last class, PDO NPD. Okay, you have the guidelines, and also gives a very detailed information about what should be the content of a PDO. Okay, so I will just copy this link, put it there, and you can read from page 42 all the way to page 49. Okay. Just to give you an example, because you might be wondering, okay, we know what is the content, we know what it has, but I want to have an example. I want to look to an example. Okay, so luckily I found an example on the web. Usually these are confidential documents that they cannot be released publicly, okay, because they might have sensitive information about the asset that is just the asset, is just some value that the company has. Okay, but there is one free here in this website. Well, not free, but it's available. It's for Bisund, Plant for Development and Operations, from 95. Okay, and you can see a bit what is the content, the logic, the explanations, the justification of the decisions. Okay, so I will, I'm giving you already too much material to read, but also I tell you to go, and I will put this link, and maybe you're going to get an exercise by analyzing this video. We have done it some previous years, but we will see if we put it this year or not. Okay, to go through this video. So that's example for the Visun. Also, additionally to the PDO, you have to deliver what we mentioned last time, was a consequence or impact. We call it impact or consequence assessment. Okay, that is going to focus more on the environmental part and on the social part of how your project is going to impact the Norwegian society, the regional environment, and also the human and the environmental. Okay, and this is slightly easier to get. There is, for example, you can search for, this is open on the web. Where is it? Okay. The bad part is that it's in Norwegian, but I guess you can translate some parts with Google. Okay, and if you see, this is part 2. The part 1 is the real PDO, what it has, all the how do you plan to develop the field, and the part 2 is the impact assessment, okay, that you have to deliver. If you see at the beginning, it has a summary of how is the asset, how are you planning to develop it, so more on the technical part, the part that is interesting for us, and then afterwards it goes to the part on the impact on the fish, on the marine biodiversity, on the social. So all of this is talking about technical, and then you go to the impact part. Okay, environmental undersökelse, det är what is it? Help? Not research, but investigation. But it's survey. Okay, ambient survey. Okay, abfall, disposal, management of disposal, etc. Okay, but here is nice that in the first part you have one technical description, and you can find this for many of the assets or of the fields that are nowadays. So I will also urge you, if you want, I will put this online on It's Learning, so you don't have to find it yourself. But also, if you want to find from other fields, I encourage you to do it. Okay, this one is from the Norske. Currently, they changed name, and it's Aker BP. Okay. And there is one more thing that if you see, let's go to that document that I showed you here. Not this one, but the Directorate. Okay, the guidelines issued by the Norwegian Petroleum Directorate. And the process, we are not going to go through it because it's specific for Norway, and also it's not part of this, it's not really the scope of this course. But after, this is the ministry, and here is where you send the PDO, the impact assessment, and you submit the company, the licensee, the one that has a production license, submits this document to the Ministry of Petroleum and Energy. Okay? And then they issue a summary to the Parliament for evaluation and for approval. Okay? And this document to the Parliament is open and available on the web. Okay? So I think here I just put the link. Let's say, yeah, Regeringen, that's government, right? Okay, and you have here the proposal that was sent by NPD summarizing what the licensee is planning to do, and also the result of the discussion between the directorate and the company. Okay, so we can open it or read it, download. Of course, some of you might need to translate, but they had nice figures. Where is it located? How many resources do we have? How do we plan to develop it? How is going to be the partnership, the ownership strategy? Yeah, and then something interesting is the economical part. Okay, what is the value of the project, and if there is uncertainty in the reserves, uncertainty in the cost, uncertainty in that, how much that's going to change the value of the project. Okay, and at the end you have the part on the communication or the comments from the NPD to the company and the answers. Okay. So also I will upload this document, and those of you just have to use Google Translate, but I think it's interesting to go through it and to see what is the content. Okay. And you will see there is a huge amount of activity and engineering, not skills, but engineering tasks that you have to make and you have to include in this document. Okay, any questions about this? Is the project planning phase? Any questions? Yeah, so I already showed you more or less. We are going to have some tasks from this project planning phase. We are going to have some examples. Of course, not on a full project, that will be too demanding and too time consuming. Maybe you will need, a course to be maybe a few years long. But we will try to check some specific examples and try to do these tasks so you get the taste of the process. Now we have the next phase, if you remember, is the project execution phase. Let's take the figure. I think we had a figure from last class. This. Okay, we are now in this part, project execution. After it is approved, after you have addressed all the concerns, after you have done the relevant modifications. Remember, they usually are small compared. It's not that you're going to make a major change in the development strategy or a major change in the production system, but they are, maybe you have to adjust some changes due to the comments of the NPD, of the directorate. Okay, and then we go to the execution. Okay, and here we have detail engineering, construction, and testing, commissioning, and delivering of the facilities that you need, of every element that you need. Okay, and these are the wells, the subsea system, the pipeline, the offshore structure, and the processing facilities, roughly. Okay, maybe more things, but these are the main components. And this can be done in two ways. One of them is to have individual contracts. Okay, that the company itself, it divides in packages. I need the wells, I need the facilities, I need the transportation, I need the offshore structure, and they go and manage the whole project themselves. Okay, and they say we're going to buy this from this vendor, this from this vendor, and they are the project managers. Okay, they sit in control. When are we going to execute everything? While so this involves detail engineering, bids, a process of bids and awarding contracts. Okay. Construction and fabrication. installation, commissioning. Okay. And there is another way, another mode, which is that you use an EPCM. That is awarded usually to one single company, and then the company, they have the responsibility to manage the whole process. Okay, so this is called engineering, procurement, construction, and management.
Could you go up a little bit again?
Yes. Okay. And this is a contract, and this is awarded. So this is to several companies that are involved, and usually the management is done by the main operating company, and this type of contract, which is more and more common nowadays, is done just by a single company, and they are the ones managing and subcontracting. Okay. Then some other tasks that we have in this period in the project execution is constructing wells. Okay. And here we have just one comment before, that you have to be careful. Sometimes you have to commission some equipment, you have to order some equipment, and you have to be sure that you choose a proper vendor. Okay, not only that they have experience in building what you need to build. For example, you need to build an FPSO, you need to build a spar, you need to build a jacket. Okay, so you have to be sure that this person that you're hiring has the experience and also has the time availability, that will be able to deliver the structure on time. Okay, that there will be no delays, because if there is a delay in the delivery, for example, of the facilities, you cannot produce, and then you will be losing money for as long as this isn't delivered. Okay, and there are usually some delay clauses in contracts saying that we have to deliver by this date, and if we don't deliver, you pay a penalty. Okay. An example, it's for example the Goliath field, that they had problems delivering the FPSO in time. Was especially a very particular type of FPSO that was round. Usually the FPSOs, they look like ships. Okay, we will talk about the offshore structures later, but they look like ships, and this one was just a round structure. And there were a lot of problems first because they didn't have exactly the experience to build this type of FPSO, and then because they had committed to many other projects at the same time, so they didn't have the capacity to go forward with this FPSO. So this is some things that you have to take into account. Some things are just taking things from the shelf and are supposed to progress in a nice way. Some other things, that are the critical components, you have to really take care of them. Then an important part is perform handover to asset. Okay, usually within the company, they transfer the ownership from the main company or from the design department to the asset. Okay, now there will be an asset called usually the name of the field. Okay, that is called Visund, that is called Goliath, and that's the one in charge of managing the asset. Okay, handling to asset, to operations. Okay, that's the name. And prepare to start up. Okay, operation and maintenance. Okay, to describe the protocols to start up. Okay, to operate, to how to use the equipment, if the emergency protocol, the emergency procedures, and the maintenance the task. Okay, and then at that point we are done. We start producing. Okay, here there is a very big hit, which is I start producing. Okay, from project execution, and then I have operations. I enter into operations. And remember here again, the length that we have here is not an indicative of the time duration. Okay, this usually might be from 0 to 6 years or from 0 to 4 years, but after you are in operation, that might be 15 years, 20 years. Okay, and in operations, typically we have, those of you who read, how does the rate usually of oil or gas, how does it go with time? Those of you that read the document, what do we have first?
Appraisal.
Huh?
Appraisal.
Yeah, but appraisal was before. Remember appraisal, we were trying to get more information about what we have in the subsurface. Okay?
You have a linear.
We have, during the production, we have one period where we are increasing the production, and that's called the ramp up. Okay? So we usually don't start just at full capacity. We just start going slowly, slowly, and these jumps, what are these jumps usually? When we are putting
Opening of
wells into production. Okay? We are either tying wells, ramp up. Okay, so that's a ramp up period. Okay, then we have usually, and we will see that there is a, it's not always like that, but we have a period where we have a fixed production, or more or less fixed. Okay, here remember in class I put straight lines and we are using nice, but remember that in real life it's going to look more like that. Okay, because you cannot usually keep exactly that value, but you will have some fluctuations up and down. Okay, so keep that all the time. We are usually, putting some simplifications, and this is called the plateau. Plateau is just like a flat surface. Okay, plateau period. And then we have the decline, okay, or called also decline phase or tail production. Okay. Yes? And these are the really three stages. If you see that in the man's life or in the human life, you have when you're a kid, when you're a grown-up, and when you're old. This is more or less equivalent. Okay, so we have all of that. Okay, but sometimes we also have, so during these operations, okay, let's put the name here because we didn't put it anyway, any place, operations. Okay. And in operations we also have maintenance. Okay, just to keep things going. And it's not only that when it breaks we are going to go and fix it, but also we have to do preventive maintenance. We have to foresee that we are going to have a problem, and we have to do some activities every certain time. Okay, so another issue is allocation. Okay, allocation, because usually we are not producing, the operating company is not the only owner of the asset. Usually it goes in partnership with many others, so they have to know how to split the cake, how much is coming from each, and they might have different, for example, different part of the reservoir. Let's say that you're producing here with one well and another well, and you commingle the production and they go to the platform. Okay, and you have two different formations, and here company one has this share. They say, okay, we want to have just 20% and the other has 80%, but in this one has 50-50%. But then comes the issue to say, to pay you for what I'm accounting here, this QO, I have to split and see how much comes from where. Okay, so that's basically allocation. I have to determine, and for that metering is very important. Okay, metering is a major task during this phase. Okay, then other things that we have are troubleshooting. Sometimes our wells start producing erratically, not with a stable production, so we have to find out what. The well stops producing or declines its production, so we have to see what is the problem abruptly. Also, one more thing is debottlenecking. Debottlenecking. Something else. And that has to do, we have usually a main product, okay? We have, it's either a gas field or an oil field. But it doesn't come alone. It comes with some associated products. So for example, if we say that it comes with gas, okay, the gas will look, of course here it will increase, but then we will have more or less stable, going up and down, okay? So that will be Q gas, and then you have Q water that usually does something like this. Okay. And remember, my processing facilities, they are sized to take this production, okay? I have made the design exactly so they will take that production, but also they have a limit on the Q gas maximum, okay? Facilities have Q gas max, allowed, maximum capacity of gas, and they also have Q water max. Okay? And I cannot go over there. So let's say that our production, this is the Q water max in our particular system. So I won't be able to produce this rate of oil. So I will have to reduce all the rates accordingly to be able to stay, so this Q water doesn't go up, but it will stay like this. But then I'm losing oil production. Okay, so that's the debottlenecking part that I try to find. For example, maybe most of the water comes from a few wells, so I'm going to close those wells. So maybe I'm going to try to do something to improve the process of the water processing, etc. So that's very important, and that actually is dealing with associated products. Okay. And something else that has to be included also in operations is improved oil recovery, okay, or methods. And those are methods that when I see that it's declining too much, then I try to apply some method. That could be, for example, implementation of drilling more wells, okay, which is usually expensive. I could try to do boosting. I could try to apply artificial lift. Can try to reperforate wells, okay. I can try to do something such as this won't decline. For example, if I'm reaching the end of the plateau, and we're going to have an exercise about that we don't end up exactly here, but that we can prolong it for a few more years, okay. Or if we are here, that it will try to pick up production so it won't decline so sharply, okay. So these are also things that we're not really taking into account in the planning phase, but that we have now to sit again in the operational phase and see how do we do it. Okay. Now comes the last part of the life. After that's done, okay, after the operations is done, comes the decommissioning part. Decommissioning phase. Okay. And as I told you, decommissioning is something that we really in the past was not paid too much attention. The fun part was to do the planning, the installation, and the operation. Okay, but decommissioning was like we are not there yet. Okay, but it's already here. Many fields in the North Sea are starting to get old. They have to get decommissioned, and there is it's not so simple as it sounds. It has quite a lot of tasks that have to be done in this phase. Okay. So in this, you have first to set a timeline and a plan. It's almost like managing a project. Okay, you have to have a timeline and a plan. So let's put okay, and a project plan. and a project guideline that we are going to make. And then also something that is relevant is that you have to coordinate with other environmental agencies, with other governmental agencies that they might be involved, especially in the environmental part and in the human part. Okay, so you have to coordinate. With relevant agencies. Then you have well plugging and abandonment. Okay, the wells I have to, because I cannot leave, if you will see later, or maybe you already know it, the well has some control structure at the top that is the Christmas tree. Okay, and we're going to take that away because it has value and we cannot leave it there. So we have to put something that will avoid that in the future maybe the fluids will come out and will start polluting the sea. Okay, so that's called well plugging and abandonment. And if you want to see, I really don't cover that in this course, but if you want to see more of that, I think there is this TPG 4200 that they have a small section about well plugging and abandonment. Okay, and it's we are going to see in just a video, but you know, just to give you a general idea. Then you have remove platform equipment. Oh, one thing that we forgot here was we have to make something that is called, in the jargon of the industry, is called engineer down and clean. Okay, down and clean. And down and clean refers to flushing and of course here we have to also stop, okay, stop production. So in down and clean we say flushing and clean tanks, okay, processing equipment, piping, okay, if we have a pipeline that is filled with hydrocarbon and we are planning to decommission it, to disconnect it, it cannot be filled with the hydrocarbon. Okay, so we have to flush it and we have to make sure it's clean, that the content of hydrocarbon is low enough to be released to the environment in case we disconnect it. Okay, that's called engineering down and clean. Then we have the prepare the offshore structure for removal. And if it's, for example, a fixed platform, something that is fixed to the sea bottom, so you have to find a way first to try to take out what is on top, okay, all the facilities. So to have a plan for, the name is his name, but I forgot. Well, to plan and remove topside equipment. Okay, and this might be, you will see a video that might be that you actually go into the platform and you try to dismantle one by one, or that you take the whole unit and you transport it to one place on shore and then you strip it down. Okay, we will see just now a video. Then you have, if you have lifting operations and transport, what I told you just now, you want to transport either the facilities or the structure to a place where it will be simpler to tear it down, to tear it apart. Okay, then you have still, that's in the facilities and the offshore structure and the wells, but then you have something that connects usually the wells to the structure. So you might have pipelines, for example. You might have manifolds. You might have, so you have also to take that away. So that might be remove or bury. Okay, sometimes they are just buried. The subsea pipelines. Okay. Then, if you left something there in the seabed, you have to be sure that it's marked, because there might be a vessel that is coming, a fisher vessel, fishing vessel, or any other kind of vessel that might hit. Okay, for example, with the net or something. So it has to be mapped in this it has to be indicated in the marine maps that you have something there. Okay, that you have still something remaining. So that's mark, or that's a register, leftover installations on marine maps. Okay, then there is usually some responsibility that you have to be monitoring that everything is okay, that everything, that you have the effects that you plan. Okay, that there is no emissions, that there is no for example, no spread of hydrocarbons that were around the structure, that there is no spread of hydrocarbons to neighboring areas. Okay, so that you have some monitoring. And the last part, which is obvious, is the recovery of material. And there is a lot of steel that you just tear it apart, the structure, and then you sell it by the weight. Okay, and then this can be recycled and can be used in some other structures, remelt and reused. Or also recycling of equipment. Okay, there is a lot of equipment such as gas turbines. Okay, you have separators, you have pumps, you have processing equipment. Okay, that they might still have a value if they go through an overhaul process, if they go through a refurbishment process, and then you can just sell it for a new platform, for another installation. And there is a lot of value in this process. In this selling steel, not so much, because the price of the steel is relatively low per ton. Okay, but on this part, you might find a treasure. Okay, you might find that you actually recover quite a lot of money from the facility. Okay, and disposal of residues. Okay, so let's see. I think I have here 3. Let's see if we can play them. It was this connector. Yeah, it's not so important, the audio. Okay, the Murchison platform, and we're not going to watch all of it, but just to show you some figures. Okay, where is it located? Okay, it's just in the frontier with in the limit with the Norwegian Sea. Okay, and that's how it looks like, the system. Okay, and we're going to they are going to decommission this platform, and then the pipelines that are joining it with the rest of the system. The rest of the system is going to remain there. Okay, so that's the production profile, and you see it doesn't follow exactly the plateau, ramp up, plateau, and tail production, but we are going to talk about that in the next hour. Okay. Okay, so here they have more or less the process. Okay, the wells, pipelines, the platform, okay, and the jacket and the top sides. Okay, the well plugin, I think this is important. Maybe we can just let it play. One is not loading, not sure why. volume doesn't work. Well, you have to put plugs of cement. Usually what you do, you try to displace the fluids in the well, and then you have to put plugs of cement, at least 4, along the wellbore, okay, to be sure that you block completely any possible access of the reservoir all the way to the surface. Okay. Then the other step, you can watch it. I will put the link. Okay. When you are bored, for example, tomorrow you have nothing to do, Friday night at 9. You see, what do I? Oh, I remember this guy told me about a video that I can watch. Okay. I'm sure some of you are going to do it, right? Yeah. Okay. So then, okay, dismantling the modules. Okay. Dismantling the modules is not very well here, but it's in another video. Okay. But then the jacket, here they show the process of taking out the jacket. Okay. After they have taken the upper part, they have to take the jacket, and it's too heavy to take it in one part. So they have to find how to cut it and take out all the different parts. And that showed a bit in the figures here. Okay. You see they lift the upper part and they left the lower part there. Okay. And that part is going to stay. They reach an agreement with the government. They say, really, we don't have to take it, but we just have to point it in the map. So if someone is navigating through the area in the future, they won't find all of a sudden this structure here. Okay. Okay. And then the pipelines. Okay, they are buried, and here maybe let's see if it plays. Okay. They just bury the pipeline, keep it in place, but bury it. And monitoring that, you will see that there will be growth with time, and there are also some hydrocarbon materials, for example cuttings. They're usually disposed just below the platform, and these cuttings, they have some oil content, and they have to be sure that it's not going to be spread through. Hey, hello. Okay, it's becoming popular, this we should charge entrance. Okay. And okay, so that's one video. You watch it tomorrow night when you're bored. Okay. And then there is this video that shows and we're going to go
commissioning completed ahead of mostly steel but successfully.
Okay, they just go the concrete structure, they're not going to take it away. That's a concrete structure that goes all the way to the seabed, and it's just too heavy to take it out. So they're just going to go just with a crane and just with a, you know, lifter, how do you call it, load lifter, and they're going to start dismantling parts of everything that is in the top of this concrete structure. Okay, and here you have, I think, some, okay, just put it and then put it in boxes, and then these boxes are going to another ship that is going to take them to shore. Okay, that's one way to do it. The other way is that you can, this was a buoy. Usually offshore structures, the tanker doesn't go all the way close to them to reload oil, to load oil, but they just stay afar, and there is another structure that connects where the fluid is pumped from the platform all the way to that buoy that is floating or is dead in place, and then the tanker comes and they are supplied with oil. So in this case, they are just transporting, pulling it with 2 vessels. They are pulling it to shore. Okay, they disconnect it from the seabed in location, and then they take it. Okay, so maybe
currently engaged equipment. The prior to and during the hookdown campaign, well plugging and abandonment is also carried out. AFD Phillips Dong Energy projects and studies for, among others, Centrica, Chevron, Shell, ConocoPhillips, Dong Energy, BP, Total, Statoil, and Hydro.
Okay. This particular company has a scrapyard here in Vats, and then they take there all the things that they have, the jacket, everything.
Meters, the base can facilitate.
And then the fun continues, starts. Okay.
All structures will provide an example.
more of a monster truck show. This shows that the truck goes over cars and then destroys them and so forth. Okay, so let's take a break, and we'll continue the second hour. Let's say in 15 minutes. Yeah. Okay. Okay. Again, if you want to, it's more or less what I told you. Okay, but focus on the Gulf of Mexico. If you want to get some more information about decommissioning, you can read from page 147 to 149 in the compendium. It's a very short article, but it gives you a nice overview of what. Also, one part that we didn't talk here is they have to cut the conductor. Okay, that's related to the well. Okay, on the well they have to. Let's maybe put it here. Okay, cut the conductor because they have to cut it. I think it's 3 meters below the seabed. Okay, they cannot be sticking a piece of pipe. Remember that the well are concentric. I guess you know that, right? They are concentric pieces of pipe. So they have to cut it 3 meters below the seabed. Okay. Okay. Now let's go to the last part of this session, and one of them is when we talk. Let's make a very simple production system. Okay, just with one well. We have the well. We have that it has a formation, a reservoir from where we are producing. Fluid is entering into the system. Then we reach the control structure that I told you about. Okay, the well, this is the seabed. Let's imagine that's a subsea well. Okay, then goes the transportation line. That's the seabed, transportation line. And here you have this offshore structure. And here on top of that, I'm going to put it very simple, but it's going to be just a separator. And here I have Q oil and Q gas. Okay, I put the bar on top. First Q, that's volumes. Okay, and then goes up. Okay, Q means that it's volumes. Okay, so if I put here a mechanical engineer. Okay, I go and I own this field. So let's put first. We're missing some details. We have the sea. Okay, and we have the fish. We have the sun. Okay. Okay, I go and I have my field, and I put here a mechanical engineer, and the mechanical engineer tell him, please tell me how much oil is passing or am I producing. Okay, mechanical engineer is going to say how much? X kilogram per second, okay, or kilogram per hour, because they are used to work in mass units. So I'm going to go and fire the guy. I cannot sell kilogram per second. What are you talking about? Then I go and I see a chemical engineer and I ask the same question. Tell me how much I'm producing, my field is producing. The chemical engineer is going to say, okay, so many kilomole per hour or per second. This guy is also going to get fired. Okay. Then finally I reach one of the bright master students from NTNU. I say, how much am I producing? And they are going to tell me the right answer. Okay, in standard barrels per day. Why? You see, it's something strange that you give a volume unit for. It will be much simpler. This remains constant. Okay, along the system. So why are you talking about volume when volume is a function of pressure and temperature, right? When I increase the pressure, I have less volume. When I decrease the pressure, I have bigger volume. But this has something very important that has this S in front. That is a standard, okay? They're all the time at the same pressure and temperature condition, okay? So that's what also the dash on top of the O is indicating, okay? Q, volume rate, but the dash on top, the line on top is indicating standard conditions. Okay. So let's put it here so you remember and I remember. Okay. And it was not a dumb decision. It's just that it's a volume, but it's all the time at the same pressure and temperature. It's at the reference pressure and temperature. Okay. Okay, now this analogy. So let's make it's a bit simplified, okay, but I think it helps to understand how the system works. Okay, so I'm going to make the reservoir is going to be like a tank. Okay, the reservoir just a big container, a tank. Okay, then I'm going to put a pipe, stick a hole into it, which is the well. Okay, that's actually what I'm doing. I'm pinching and making a hole through the reservoir, and then I'm going to put the path. Okay, let's say I'm going to put this pipe path all the way and I will put here my separator has a constant pressure equal constant. Okay, now to represent in this analogy, so this is, let's call it a mechanical analog of my production system. So this is what I call production system, and this is the domain of a production engineer. Sometimes reservoir, but mainly production engineer. Okay, we are from near wellbore to well to control of the well to transportation and all the way to the processing facilities in the platform. Okay, but we are making an analogy that say, okay, I have a tank, that's the reservoir, but then I have to put some restriction that indicates the pressure drop that I have. The reservoir pressure is measured far away from the well. Okay, is if I don't produce anything and I leave everything in equilibrium, at which pressure does it reach? Okay, and that's the reservoir pressure. Okay, average reservoir pressure, and that's the pressure I'm going to put inside, PR. Okay, then for the flow to go from that point all the way to this point, how do I call this point inside the well? PWF. Okay, this point not big enough. Okay, PWF, flowing bottom hole pressure. Okay, and that's this PWF. Okay, and to go from here to here there is a drop. Okay, that indicates so this indicates pressure drop in the formation. Okay, yes, so now I go and continue forward all the way to the surface here, and here I have another pressure which is called PWH, the wellhead pressure, or to follow the same nomenclature, flowing wellhead pressure. Okay, and that the path from the bottom of the well to the top also I can represent like a loss. Okay, like a restriction. I'm putting just mechanical restrictions in the pipe, and this represents the pressure drop in the tubing. Okay, then I have one more, which is the pipeline, right? So this will be PWH. Okay, until I reach the separator. The separator, think of it like the thing that no matter what, okay, it's like your anchor. Okay, it's like you say this is the invariant thing in life, is the pressure of the separator. It's all the time kept constant. Okay, and how is it kept constant? Okay, we're going to talk about that later, but it's kept constant. Okay, the pressure doesn't change. Okay, so what happens in this very simple analog? If everything is closed, so I need something more, right? I need to have something that controls open or close. Where do I put it? No idea. Inside the tank?
The Christmas tree.
Yeah, the Christmas tree, it should be
On top
here,
of
right?
it.
After this. Right. So let's make space. I can do this. You will have to screw up your drawing, or maybe I screw up a little bit. Okay. Okay, and here I want to make it very simple. Okay, like something like this. Yes, okay, and that's the pressure upstream the choke is the wellhead pressure. Okay, and this is, how do we call this pressure? Downstream the choke. So here I think we are missing the choke. Okay, this is what we are saying is the choke. Okay, my control element. This, let's call it PD. Okay, pressure downstream the choke. So if I leave, let's say I start at time zero, okay? And here you have your engineer, your petroleum engineer from NTNU that is looking very closely how much we are producing. If I leave the choke open, okay, don't change it with time, how do you think the production is going to look like with time? Is it going to increase? Is it going to keep constant, or is it going to decline? What happens if you have a tank and you just open the valve and you start producing? How do you think the rate is going to go? So let's think it just, okay. The flow rate through the system is proportional to what? Or is somehow related to what?
Pressure.
The pressure difference, right? So the rate is a function of the difference between PR and P-SEP, right? What happens when I start to produce things from this tank? The pressure is going to reduce, right? If I take things out of the tank. So what should happen with the rate with time? Should decrease, right? Because there is less driving difference, pressure difference in the system, along the system to so you will see something like this. Okay? Right? Everybody agrees? Yeah? The rate is somehow related with the difference in pressure, and as a difference in pressure, this is remaining constant. Okay? The delta P is P reservoir minus P sep, but this is all the time constant. But every time I take out material from the tank, this pressure is going down and down and down. Right? Yes? So now we have discovered the first production mode in a production system. Okay? This is called what I call mode B, okay, which is decline mode, or also called constant pressure mode. And if you see it means that I don't make any change in the choke. The choke is fixed, is a fixed position, and my production is going to go from a very high value and start to decline all the time, declining continuously. Okay, when do I use this production mode? For which production? If you see the maximum, let's say I make this system, I make this facility a separate facility. Okay, I design it, I build it, etc. And it should have, what should be the capacity of this facility? This we call QO initial. Okay, so it should be able to process that rate, right? The initial production rate. But if you see, it's going to use that only the first millisecond of the first day of the first year of production. After that, it's not going to use it anymore. After that, it will be just extra capacity that you never use. So you paid a lot of money to pay for a big separator, for example, and you're going to use its full capacity only the first millisecond of the first day of the first year. Okay? Doesn't really make much sense, right? So usually I use this production mode when I already have, let's say I have an asset here. Okay, I have a reservoir that I'm producing from it. let's say I have the wells and they are going to the facilities. Okay, let's call this production system 1. Let's take another page. Okay, and this system in time, it was producing nice, okay, and then it started to decline, okay, but it looks like, let's say I'm looking at this particular point in time, I have some extra capacity, okay, because it started to decline. So really now my separator on my processing facility can have some spare capacity. So what I do in this production system, let's say another reservoir, another well, I say, oh, here I can produce, and the value that I'm producing is within the spare capacity of this plant, of this platform. So what I do, I will just do a tie-in and send the production to that existing processing facility. Okay, so that's called a tieback or a satellite development. Okay, so this is for satellite fields, okay, that are tied back to existing processing facilities. Okay, these are usually not used for standalone, not used for standalone projects. Okay, okay, for the reason that I told you, if we design our system for this rate, it's going to be using it just for the first day. Okay. Now there is another way I can produce that system, and it's called mode A, and that's plateau mode. Okay, or a constant rate. Okay. And what do you think I will have to do with time to keep the rate constant? Okay, well, how would you do it in this simplified system? You initially, let's say, I leave the close partially closed, the choke partially closed, okay? And then I'm producing a value. Then when this pressure starts to go down, I open the choke a little bit, right? And then the rate goes up. I was producing this, then starts to decline, due because of the reservoir pressure starts to decline. And then I open the choke a little bit. So I go back into plateau. Start to decline again, up. Start to decline again, up, 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 up. And I will be able to maintain relatively constant the rate of that reservoir. Okay? But will I be able to do that forever? No? What will be the limit? When I reach fully open choke, right? When the choke is already all the way up, then that's where I don't have any more control on my system, okay? And that's where I enter from mode A to, what happens when I don't change the choke? Mode B, okay? You enter into mode B, you enter into decline. Okay? Let's put it B like that, or let's make it nicer. Okay, so this production system is suitable for new developments with standalone facilities. Okay, because here at least I'm making sure that I'm using the facilities for a longer period of time, so it pays for my investment. The production, the revenue that I get from the production, it pays for the facilities. Okay, this is very important, and this is fundamental to understand in this course. Okay, these two modes, and use the analog. But when we start to more complicated systems, okay, with multiple wells, that you have equipment, that you have boosting, you have to keep that idea in mind. Okay, this mechanical analog is very simple. You might think even it's kind of trivial. Okay, but it's important for you to understand how do we operate the system. Okay, and I have an example. If you go to my website, I will put also the link here. Maybe you can open it. Those of you who have computers or with the cell phone, I'm not sure if it works. Okay, in resources that I told you, you go to useful links and tools, operate a field using the field simulator. Okay, and you have exactly the same simplified system. Here on the left you have the reservoir pressure with time, and here on the right you have the production, the field rate with the number of days. Okay, and here you have the choke that you can change from completely closed to completely open. Okay, and here are some parameters that you can change. This is the decline of the reservoir pressure has versus how much material I'm taking out of it, the initial reservoir pressure. These are all of these constraints that I told you. Okay, these are the value of these restrictions. Okay, how big, how small, so you can play with that if you want. And here it's saying that you have 7 wells that are draining from the same reservoir and they are operating in the same way. Okay, so I click start. If the choke is closed, so I don't produce anything. Okay, reservoir pressure remains constant, the rate remains 0. But then I start to open. Okay, and I start producing. But if you see, if I keep it constant, okay, if I keep the choke opening in the same position, I start to decline immediately. Okay, so you can try even to make a small experiment. So here I click stop, reset, and start again. Okay, so I will start here, okay, with some production. If I want to keep the same level of production, I have to open. Okay, it cannot be too abrupt because then it jumps too much. Open. Okay, and here we didn't reach the end of the plateau. Okay, clear? So homework also, just go ahead and try to play, understand, change the values, play a bit with it, but it's exactly the same that I was explaining you before with the mechanical analog. Okay, so let's paste that here. Okay, but fundamentally 2 concepts, decline mode and plateau mode, and one is for new developments where I can build standalone facilities. The other one is for satellite fields that are using something that is already existing. Okay, so now it's your turn to give something to the class. Okay. Okay. Yeah, maybe we can take that now. Usually has a rule of thumb. Okay, we take for oil fields for mode A, for fields operating in mode A, okay, usually has a rule of thumb. I drain 10% of the TRR, which is total recoverable reserves in a year. Okay, I drain 10%, and total recoverable reserves is what? Maybe you heard before, you have initial oil in place, okay, initial gas in place, okay, that's the overall volume that I have in the subsurface. Okay, this in SP nomenclature is called N, and this in SP nomenclature is called G. Okay, initial oil in place, initial gas in place. And then to find the total recoverable reserve is just N or G times the recovery factor. How much I'm planning to recover from that volume that is there. Okay, RF is recovery factor. So if I have like a rule of thumb, like initially if someone wants to see, okay, if I want to produce it in plateau mode, what will be the rate or the constant rate of that field? Okay, I just take 10% and then divide that 10% between the number of years by the number of years of days in a year, right? Yes or no? So to find out the rate, how will you find the plateau rate? Okay, it's N times recovery factor times 0.1, right, divided by 365, and that gives you the rate in standard barrels per day. Is it correct? Yeah, I'm draining that in 1 year, and that year has 365 days, right? That's for oil, okay? That's for oil. And oil is not red, sorry, but we should put it with the color green. Okay, and red is the gas. For gas is closer to, is something between 0.03 and 0.05 per year. Okay, instead of 10%. Okay, instead of 0.1. Okay, and you can read about that. It's in the compendium again, if you want. Let's see where it is, where they talk about plateau. Here. Okay, I think they talk about it here. Okay, 2 and 5% standard oil in initial oil in place. Okay, so that's page 18. But truly, the plateau rate, you define it through the economical analysis. Okay, you calculate, you assume a plateau, you calculate the size of the facility, the cost of the facility, and then based on that, you calculate the value of your project, and you decide if that's a good value or not. Then you can go up or down, and you see if that increases or decreases the value of the economical value of the project. Okay, now just to finalize, now it's on your side. Okay, we have, what is the main difference from what you read between onshore and offshore development? Mm-hmm. Okay, the first is how the production profile looks like, and that's the first image that you had in the notes. Okay, how does it look like? The ramp up in an onshore field usually, and that's only if you have onshore fields, usually you have, there are neighboring fields of easy access to tie in production. Okay, so the production profile usually looks like, in an offshore field, the ramp up is very steep, then plateau, then decline. But in an onshore field, usually it's very slow, increasing very, very slow. Okay, until you reach maybe plateau, and then you have decline. Okay, so the ramp up period usually is longer ramp up. Okay, than in offshore. Other thing is the appraisal. How is the appraisal? Okay, the appraisal is much longer, okay, and actually it overlaps with the production. Remember that in offshore we had to take the decision if to do more appraisal or not, and then we start with the design, okay. But that phase is over. We usually don't repeat the appraisal. Appraisal, remember, is drilling more wells, exploration wells, to find the extension and running more seismic, okay. But usually here we can start producing, we tie in, we continue exploration, we tie in, and then so sometimes there is longer appraisal and overlapping with production. Okay. While here we have very short ramp up and very short appraisal. Okay. And it really is motivated in a way that you want to get production as soon as possible. Okay. You have spent already a lot of money doing exploration, you have spent a lot of money doing design, you have spent a lot of money to order the facilities, to order the structures, to build the wells, and then you are bleeding, okay? You want to get cash flow as soon as possible. So you cannot really wait more years to try to get more information about the reservoir. You say, I just want to produce as soon as possible to start getting a healthy cash flow, okay? To get a healthy okay. What else? I can here test. If I do it very slowly, I can really start producing, put for example several wells, and I start producing and see if there is, how is the communication, or how is the structure of the reservoir, if it's really according to what I thought initially. Okay, and I can start correcting it. So I can test and verify reservoir communication and structure. And I can really use that information, use production data to improve reservoir models. Okay, if you remember, reservoir models is what we use, is central in the, either if it's very simplified material balance, if you're using a simulator, is central to be able to predict how much you can produce from the reservoir, from the formation. So here we really have data production, and we can put it into the model and make it better. Okay, here really you don't acquire much production data to improve my reservoir model. Okay, so that's why Dake in the notes, he says that really sometimes it can be just a cartoon. Okay, something that you did your plans based on that, and when you start producing, you realize that your reservoir is completely different. Okay, and then you have to take actions, and that's where it says the reservoir engineer should maybe consider moving to another asset. Okay, because you might get into trouble for your initial model. Okay. Yes. Some more things. Okay. Here you have to plan ahead for water and gas injection. Okay. And sometimes that creates some problem, because you plan to put your injectors here, your gas injector or your water injection, and then you realize that there is no communication. It's going to make no effect, because for example there is a shale barrier between the producing and the injector well. Okay, and it's not going to have the effect, the pressure support effect, and the displacement that you expected. Okay. While here it can be, you can be delay the planning of gas and water injection. Okay, and here maybe it will be necessary to review the planning and the models on the go. Okay, as you start reading, as you start producing, maybe they realize that some of the assumptions that they took originally are not valid anymore, or they are completely different. So in that case, if you can still make some changes, they revise the plan, for example, the drilling plan, or maybe they can even take the decision to stop and revise everything. Okay, which is the kind of the not very common not very common situation. Anything else that I'm missing that you read? No? Okay, that's more or less like a summary of what Dake writes in the chapter. Yeah, maybe just to conclude one. So the other thing you had to read was oil versus gas developments. Okay. Okay. One thing is the transportability of oil and gas. Okay. Okay. Oil can just be sent in tankers. Okay, you can just load it in tankers, and then the tankers, they can send it everywhere in the world, any place in the world that you wish. Okay, they just sell like a commodity. Like you go to Clasusen and you buy everything you need. So oil is shipped in tankers, and it's very convenient. And the thing about oil is that there is a lot of energy in that barrel. Okay, energy. It has a high energy density. While gas, to transport gas, you need to have, there are two ways. One, you need to have a pipeline in place to transport the gas from one place to the other. Or you need to have an LNG plant, okay, which you convert this gas into a liquid, and then you can carry it more or less the same way as oil. Okay. But the two things, the pipeline, one thing is important. It's not only that you have the pipe, but you have someone at the end of the pipe that is going to use what you are sending through the pipe. Okay, it's not enough that you just have the pipe. You cannot just blow it to the atmosphere. Okay, you have to have someone that is going to use that gas. So usually for gas, we need to have a contract. So how did I call that? Okay. Okay, and the contract specifies certain time. Okay, specifies also certain amount. Okay, that you want, certain flow rate that you want to deliver. You specify the price of the gas. We are willing to buy that gas for this amount, okay, of money, for this amount of dollars per standard cubic meter per day, or if you are working in field units, million standard cubic feet per day. Okay. And also you want to have certain gas specs. Okay, you want that the gas that you get from that particular field all the time will have the same, or more or less the same, regular properties. Okay, such as the heating value. Okay, because what happens if you burn that gas? Initially you got some gas, you burn it, you get quite a lot of energy out of it, but then the next day comes gas and you burn it and you get less. Okay, less energy. So you want that it will have the same heating value, or they will be within a range. Okay, and more things that are checked are the content of nitrogen, CO2, and H2S. Okay, so for gas, the conclusion is you need to have a buyer, okay? A buyer and a contract. You need to have a destination for gas, and you have to have an infrastructure. And it's more or less the same with LNG, because LNG, you have a plant that converts the gas into liquid, then the tanker is very special, it's not a normal oil tanker, and then you have to have some place where they convert it back to gas, from liquid to gas. So you have to have, if using LNG, it is necessary to have an LNG infrastructure. Okay, sending a facility that is sending LNG, then the carrier of LNG, and then the receiving LNG. Okay, so gas, I need to have a market, I need to have a buyer, I need to have a contract, I need to have a commitment. Oil, I can just produce, put it in the tanker, and then wait who buys it. Okay, it's like having a product that is easy to sell. Also, the price is price of oil is higher than the price of gas. Okay, we are almost about to finish. So that's why this is one of the reasons why oil fields have a plateau between 2 and 5 years, but gas fields have a plateau of between maybe 10 to 25 years. Okay, and this is due to a contract. Okay, you make a long-term contract for 10 to 25 years. So if you see we are plotting the plateau for an oil and a gas field, it will look something like you have the ramp up, then you have constant and then decline. And I should use, let's see if I can change the color. Yes, okay. Okay, and then you have the Q of the gas, that you have again more or less the same ramp up, but then the production is much longer for a longer period, and then you start the decline. Okay, and that's Q of the gas. Very simple, very practical reason, but that's why there is this difference between the two. Okay, and gas and an oil development. Okay, we finished. Any question before we close? No? Okay, good luck on the weekend and see you on Tuesday. Okay?
Tack ska du ha.